All right, Algebra 1 students, welcome back to Topic 6, and actually your final lesson in this topic, 6.9, Writing Exponentials from Word Problems. This is a shockingly useful lesson, one that I've used actually many times over the last few months. So my wife and I have been looking into buying a new car, and we've been doing a lot of percentage increase and decreases. So let's get to it. I guess before you start any math, I will tell you right now that you are 100% going to want a calculator for today. We're going to be dealing with some fairly large and maybe some fairly ugly numbers. So you have a few options for calculators. I have a blue TI-30X2S, which is one of my least favorite calculators, but it's the one our school has, so it's here if you want it. Any calculator where you can type multiple digits and operations at a time, like 30 times 0.02 plus 7, something like that. If you can type them all at once, you're good to go. That means the iPhone calculator, not good to go. If you want to use a calculator on your phone, my recommendation is always the Desmos Scientific Calculator. Okay, the Desmos Scientific Calculator is an app in the App Store. It's different than the graphing calculator. Or you can just Google it, and when you Google Desmos Scientific Calculator, the very first thing that comes up is, shockingly, the Desmos Scientific Calculator. It looks like this, and this is what the app looks like as well. And this way you can do like 73, whoops, not N73, 73 times 3 minus 2 plus 7. You can do many operations at once, and that's what you'll need for today. Okay, there are 3 opener questions on this first page. You need to bring a little bit of logic into it as well. So, you go to a store and find a sweater that originally cost $60. It's on sale for 35% off. How much does it cost now? And as a hint, the answer is not 21. 21 actually wouldn't make sense because what's 50% of 60? I think many of you are comfortable realizing that 50% is half off, right? So 50% of 60, if you got half off the price, would be $30. It's not even 50% off, so it's got to be more than $30. In fact, that probably brings up a good point of how do you change 50% to a decimal? Well, currently the decimal is sitting to the far right of 50. A percent, think por ciento, if you're speaking Spanish, it's for 100. It's out of 100. And so we need to move the decimal 2 places to the hundredths, 0.50 or 50 hundredths. And you do that with every percentage, so you'd move the decimal twice over here if you wanted the decimal instead of the percent. But that's enough help. Let's see if you guys can figure out the answer and see if there's any other ways to do it as well. There are 3 of these. I wish you the best of luck. And then once you're done, let's unpause and see how you're doing. Ready, set, go. Now, you might have noticed on most of these problems there are 2 different ways to do this. So I'm going to give you the long way around first. And this is actually the way I find most people do this. What most people do is they realize that 35% off means 35% of the original price. And most times, many times in math, when you see of, that's going to mean multiply, right? Half of something means 1/2 times something. So if we see 35% off, what many people try and do is they try to do 35% times 60. Now, although some calculators have a percentage button, really what you're doing here is you're doing 0.35, I moved that decimal 2 spots, times 60. And we need to go to our calculators for this. You can do this by hand, but that's maybe a lesson for another day. We're going to do 0.35 times 60. And we do get 21. So you might be thinking, oh, 21 is the price of the sweater. Except this is the percentage off. So if you're 35% off of the price, what they're telling you is you are saving, or you get $21 off. And so how do we do the final math? Well, we take $60, we subtract $21, and that will give us $39 for our final price of that sweater. You're saving more than 1/3 of the price. That's actually a pretty good deal, I feel like, for good clothing. All right, we're going to go ahead and skip C for now. We're going to skip on to our next problem, and then we'll come back to this. You make $10 an hour at your job. Due to being awesome, congratulations, your boss gives you a 5% raise. If you get a raise, you make more money. I hope you knew that. How much do you make now? Well, again, we could start this problem the same way. We could do 5% of, and we're making $10 an hour. It's a pretty common minimum wage at this time, though arguably it should be more. And then we need to take the decimal that's here and move it once, twice. We need to add that extra 0. So really what we're doing is 0.05 times 10. And if we do on our calculator 0.05, oops, we'll get rid of all this, 0.05 times 10, we find that is 0.5. Or 0.5 in terms of money, I think, is 50 cents. And you might be a little disappointed here, but you're not now making 50 cents an hour. That would be silly if you got a raise. We need to take the $10 and add on the 50 cents to get your new salary per hour of $10.50. Not a huge increase, but some increase is better than none, right? Some might argue you could do more and earn more, but either way, that's fine. $10.50. So we saw off was subtraction, a raise was addition. Let's go ahead and move on to our last one. The population of the world is currently at 7 billion people. This is increasing at a rate of 1.11%, and let's assume that rate is per year. All right, how many people will there be 3 years from now? Let's do the long way around. We're going to take 7 billion, right? Here's 7,000, 7 million, 7 billion people, and we're going to multiply that by 0.0111. And this was actually a true fact a couple of years ago. Might be a little bit older now, it's 2022, but it's pretty close. So we're going to take 7 billion, and I'll get rid of this 7. Here is our million, billion times 0.11, nope, 0.0111. So we get 777,000,000. 777,000,000. Going backwards, we find that we get 77 million, which doesn't make a lot of sense because we can't have fewer people if you're increasing at a rate. So we need to add that on to our 7 billion. And hopefully we can do this in our heads. If you can't, we'll try adding straight down. I tried to line these up decently. We get 7,077,700,000 people in the world. However, this is per year, so that's just 1 year. So after 1 year, we've added 77 million people. That's a lot of people, but we're not done yet. We need to find how many people will there be 3 years from now. So what do we do now? Well, we don't just keep adding 77,700,000. That's not how percentages per year work. Once we did 0.0001 or 0.0111, we need to now do it again. So we need to go through and do times 0.0111 of our new number. And help me, is 1.11% going to be larger or smaller than the 77 million? Well, if you do a percentage of a larger number, we should get a larger answer than what we just got. But let's check it out. Okay, so we go through and we say 7,077,000. Let's make sure I got this right. I missed an extra 7, my fault. 0.0111 times 0.0111. And I put commas in. Desmos doesn't like commas. Sorry for readability, Desmos. 78562. So this is going to equal 78562 470. Whew. All right, we have some more math to do here. So we go through and we need to add that to the 7,077,700,000. So we're going to add that on to 7,077,712,123. There we go. I think I put too many zeros there. Oh, maybe not. 1, 2, 3, 4, 5. Yep, that looks pretty good. Notice they wrote this in scientific notation. I need to move the decimal 9 times. So 7156. There we go. 262. Okay, good so far. 47. And if we count 9 places, we go 1, 2, 3, 4, 5, 6, 7, 8. I need to go one more place to a 0. Woo! got even more people. So we went from 7 billion to 7,077,700,000 to, if we put our decimals in here, there we go, 7,156,000,000, and you get the idea. We're actually going up faster and faster every time. This is, though, only after 2 years. We have to do this a whole nother time. There's got to be a better way. So hopefully you found the better way, but we're going to jump back to the beginning and see if you know it. It all has to do with the percentage. So how does this work? Well, if we have an item that originally cost 60%, then what is that in terms of a percent? Well, this cost rate here is 100% of this item's cost. 60 is 100% of its value. It's everything. So if it's on sale for 35% off, what percent value is left? Couldn't you argue that 100% you're losing 35%? That's 65%. So if it's 35% off, isn't there only 65% left? I wonder what would happen if we took our $60 here and we multiplied it by 65%, or if we did $60 times 0.65. Let's check that out. 60 times 0.65. We need to clear all this junk out, that's for sure. So we had $60 times 0.65. That's 39. Well, doesn't that actually match the answer we got with one fewer steps? Instead of finding 35% off and then subtracting it, we were just able to say, well, 35% off, that means 65% is left, and we multiplied. Does that always work? Well, let's see what happens here. Currently, you make $10, which is 100% of your salary. That's everything you make. But then you're gaining a 5% raise. So doesn't that mean you're at 100% plus 5% more, or 105%? Okay, well, then could we take our $10 an hour and multiply it by, decimal moving here 2 spots, 1.05? Let's check that out. $10 times 1.05. This is 10.5, or add the 0. $10.50. Have we found an awesome shortcut here? Well, how does this apply down below? We have increasing at a rate of 1.11%, increasing, so this is our current total. We're increasing that at 1.11%. So 100 plus 1.11% gives us 101.11%. So what happens if I take my 7 billion, that's million, here's billion, times, and let's move our decimal here, 1.0111. Let's check this out. So we have 7,000, nope, no decimals, 7,000 million billion times 1.0111. All right, it says 10 to the 9th, 7.0777. Notice up here we had 7.0777. In fact, if you move the decimal that many places, you will get 707770000, which is the same answer we got before. But wait, we just found that this is right here. And we are trying to use a rate of 1.11%. So what happens if we multiply this, which is the same as this number, by 1.0111 again? What if I multiply by 1.0111 again? So this guy then is going to become something else, and that's easy to do on here, times 1.0111 again. 7156262, isn't that what we got down here? So that would be after 2 years. How would I do after 3 years? Couldn't I just go through and do times, we'll do this in different color, 1.0111 again? So times 1.0111 again, and now we have the population after 3 years. Move the decimal 9 places, we have this glorious answer right here, and we are set. But wait, isn't there an even faster way to do that? Couldn't we have taken this initial value that we started with, this 7 billion, and instead of doing 1.0111 times itself 3 times, couldn't we do a shortcut? Couldn't we do something like 7, 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1.0111 to a power? Right? Power-wise, there are 3 of them here. So couldn't I do to the 3rd power, where we had an initial value, and then we had our rate plus 100% to the time power? And I think if I do this on here, and notice that the shortcut on here, I'm going to go ahead and do the caret, this up arrow, and I know it's hard to see because you can't see my keyboard, to the 3rd. Doesn't that give us the exact same answer again? And it does. So that is looking pretty swell. It seems like we learned a few things on this first page. First, if you want to shortcut the find a percent, then add or subtract, we just add or subtract the percent to 100 and do it once. Second, if a percentage is acting upon a population or a number for multiple times in a row, instead of doing multiple math equations in a row, we can just take that percent and we can take it to the power for the number of times that it's happening. All right, let's summarize this and see what we can do. Oftentimes, we are presented with a rate at which a quantity increases, that's like percentage growth, or decreases, which is decay. However, as we saw on the opener, a 5% increase does not mean 5% of the number. That'd be very, very small. Instead, we would write this 5% rate as 105%. This is because we want to take the full quantity, aka also known as 100%, and add 5% for the growth rate. So let's practice a few below. Write each percent increase or decrease as a value added or subtracted from 100%. Let's do it with me. A quantity increases by 3%. Well, the quantity is 100%, right? If it's increasing by 3%, then the new quantity is 103% of the original. An item of clothing is 20% off. Well, it was originally 100% of its price. Take 20% off. It's now 80% of its price. An animal population, that's 100% of the animals, decreases, sad, by 7%. We're now down to 93%. Now, it is much more common to not write percentages in equations. Having to put the percent sign is usually an extra symbol we don't include, and not all calculators have that either. Instead, this percentage rate is given as a decimal. So, don't forget to convert a percentage to a decimal. We either divide by 100 per 100% per century, or we move the decimal 2 places left. So let's convert each percentage below to a decimal. And bonus, can you see how to do this on your calculator? Because there is a way to do it on most of the calculators we have. So try these, unpause, then we'll chat. Ready, set, go. All right. For each of these, we have 0.20. You take the decimal, move it twice. It is common to put the extra 0 in front to show that there's something there, but you don't have to. Sometimes that confuses students. I'm going to put it, though, each time for these guys. I won't for the last one. We'll see why. We move the decimal twice. This is 0.90 or just 0.9. Move the decimal once, twice. That's a tricky one, 0.05. And the last one, 1.04. All of these are the decimal forms of our percentages. All right, let's go ahead and put everything. Oh, no, I'm sorry. We've said we would do this on the calculator. Well, that's not too bad. To do this on the calculator, and I'll just show on this blue one here, if your calculator has a percentage button, like this guy right here, you can use your calculator to do this. The way you do it, and let's just demonstrate 104%, is you would do 1, there's a 0, 4, and then to access the percentage, we do second and then percent. So on your calculator screen up here, it'll look like 104%, and then press enter or equals. When you do that, your calculator will take the 104% and immediately convert it to 1.04. It'll take your percentage and make a decimal. So you can do that. However, there are going to be problems on your test and your quizzes where you need to know how to convert a percent to a decimal and back from a decimal to a percent. So just be ready. Okay. So let's put everything together. We're going to write an exponential equation, an equation has an equal sign, to model each scenario. So let's use problem 3 from the opener as an example. The population of the world is currently at 7 billion people. It is increasing at a rate of 1.11%. We're going to write the equation in the form of y equals a times b to the x. Before we do that, though, we need to understand what the values of a and b are for the situation. Now, of course, y is the output. That's the answer after you do all the math. A, well, if you think about what we did on the front page over here, notice that a is the initial amount that we began with. So a is the initial value. Notice that a doesn't have a power, and if it doesn't have a power, there's an invisible 1 here. There's only one of the initial value. B, though, is the rate. It's written as 100% plus or minus. This sign means plus or minus. Sometimes we'll use plus, sometimes we'll use minus, of the increase or decrease. By the way, this B value will be written as a decimal. X is the input. So, once we're here, let's see what we can do. The population of the world is currently at 7 billion people. It's increasing at this rate. Write an equation in the form y equals f of t to model this situation. Well, we know it's y equals. They told us that over here. What's the initial value? The initial value is 7 billion people. Let's work on those. There's million. Here's billion. We're going to go ahead and put some parentheses, and I would suggest you put parentheses here. And then we have two things to do. First, we need the rate. We already converted 1.11%, but let's do it once more. We are adding on this number of people. So this is 101.11%, or as a decimal, move this twice, 1.0111. 1.0111. This would only happen once, though. It would only show us what happens after 1 year. We want to see after t years. So to multiply by 1.0111 in any number of times, we put a t as the power. And so if we wanted to know the time after 10 years, you replace t with 10. After 50, replace t with 50. All right, second question. Your car is originally worth $30,000. It depreciates, and remember, depreciates is like decays or loses value at a rate of 25% per year. Oof. Write an equation in the form of, y equals f of t to model this situation. Well, I got the start. Y equals, now what? Well, initially your car was $30,000. That's our initial amount. Do we want to put a 25 here? Well, no, that's the percent. Do we want to put a 0.25 here? No, that'd be too small. That would give us 25% of that. That would mean that you lost 75%. We started 100% and we are losing 25%. That means 75% is left. And as a decimal, that is 0.75. How many times does this happen? Well, as many times as you would like to plug in a value for t, so we need to put a t up here, and you can replace t with any number that you would like. This is really our main theme for today, so all we have left is a bunch of practice problems. In fact, your group, if you're doing this in person, or you, will be receiving a set of 10 problems. A shameless plug right now, these 10 problems come from a Teachers Pay Teachers site called Math is Funtastic. They do wonderful work. You should totally check things out. And so I'm not actually going to show you all of this. I'm going to give you really one sample problem, the same one you see on their site, but I don't want to give away their work. That would be rude. If we're in class and I'm not publishing this for the public, we'll do more. But for now, you're going to see 2 blank pages. That's where things go, and we're going to explain how this works. Each problem has a description, if the problem is growth or decay, and a numerical answer. And let's look at that example down here. Right? We have a problem. Here is the description. Value of a car, 30,000, was a 6.5%, optimistic. What will the value of the car be after 10 years? It has a problem included too. There's also going to be a decay and a numerical answer. Now, it's not this easy because if you look at this down here, they give you all sorts of descriptions, growth, decay, and answers scattered everywhere. So it's really a matching game. And that's where these boxes come in play. With your group, you need to solve each problem. So you need to look at the description, which also has the problem, and you need to solve it. To solve it, you need to show the correct work in the box that will match the description, which is the big piece. You can show the setup, then do the work on your calculator, and lastly, write the answer to at least 3 decimal places on the paper. For example, if you were doing the car depreciation problem from before, that's this guy up here. Your car is originally worth this, it depreciates in value, write an equation, we did that, wonderful. But if we went one step further and we wanted to know how much our car would be worth in 5 years, we would take this t value that's right here and we'd replace it with 5. Alright, not too bad. We replace it with 5, and then we have to do some work on the calculator. You don't have to show me what you plug in on your calculator, but I need to see a setup, this, and an answer, this. Okay? Then, all of this work is going to go in one of our boxes. This is on a piece of paper, so you're going to show me that work. Lastly, if we're doing this in person, you're going to take the descriptions, first part, growth decay, second part, and the answers, and you're going to set them on top of the blank spaces. You're going to be working with groups of 2 or more, so you're going to put 5 of the answers on the front, 1, 2, 3, 4, 5, right? And then on your group mates paper, you're going to take the other 5 and put them on the back. It would be silly to put them all on the front, or to try to put all 10 on one piece of paper because I need these for other classes. We're not taping them down, and you'd have to be flipping this paper back and forth. You, however, every person will need all 10 problems, 5 on the front, 5 on the back, written down. But then you're just going to take 5 of the problems and place them on your front. Your group mate will take 5 and place them on the back. Every student must have the setup and the answer in each box. So, because I don't want to make this public, but I did purchase this, if you would like or you are required to do this activity, please let your teacher know, and they will probably tell you where this activity is located privately so that other people cannot get it. It's a great activity, and you do need it to finish for today. So thank you for tuning in. Hopefully you got something out of writing and maybe even solving our exponential word problems. Seriously, I'm in the market for a new car right now. We've been doing a lot of exponential growth and decay with the car market. Happens often. I've also refinanced my house. That comes up. And I've just bought things on sale. Also important. I am excited that you have now finished topic 6. We have some review and a test coming up, and then we are done with our exponentials really for the year, and we're moving into our last type of equation, quadratics. Congratulations, you're a rock star, and I'll see you back for topic 7.